Hey guys, welcome back to the new video in tutorial series Introduction to Kubernetes. Today we are going to talk about horizontal pod autoscaler. Little bit about me, I am Jainish, software developer. Here are the links which you can use to follow me on GitHub, Twitter, and LinkedIn. Let's get started. So what is horizontal pod autoscaler? So horizontal pod autoscaler is basically used to scale number of uh, pods in replication controller, part of deployment or part of stateful set uh, to to serve the traffic based on CPU utilization or based on memory utilization, right? Now, as I mentioned, HPA or horizontal pod autoscaling cannot be applied to DaemonSet because DaemonSet is only one pod per node. So how does that work? So basically, let's say you have a deployment of Nginx pod and you are serving some static content, let's say a website, and during a daytime, you will get lot of traffic. Let's say you posted some blog which became a popular and it's trending, which means you will have lots of requests and to serve all the requests, Nginx CPU utilization will be higher. So now in that case, instead of watching it and adding or scaling the pod for Nginx manually, you can set horizontal pod autoscaler, which can scale pod based on the CPU utilization. So let's say if you are saying that, hey, if CPU utilization goes above 60% for a pod, add new pod so that the load can be shared and chances of CPU, basically a pod crashing because of lack of resources are very less. So let's get started and let's do a demo. So I have uploaded the code for demo into the same GitHub repository for my all the tutorials, Kubernetes introduction. And for this, I have created a new directory called horizontal pod autoscaler. And so let's look at the deployment first. The deployment is very similar as we went through the deployment tutorial. Here, I am trying to reduce the CPU utilization so that uh, we can have it bump up the number of pods when we hit the traffic. So it is very similar. We are using deployment objects. Then I have the service as well, very similar to the one we were using in previously. And this is the horizontal pod autoscaler. So the kind is horizontal pod autoscaler. The API version is V2 beta as of now. And here we are specifying the target that, hey, I want to uh, keep eye on deployment name engine node version deployment. Uh, and the minimum replicas but it should have is 1 and maximum replicas is 10. So for example, if you don't have any traffic coming in, it will run with 1 replicas. And let's say if you have loads of traffic, it will go up to maximum 10 pods running at the same time. And we are saying that scale only when the CPU utilization is average, it's above 50%. So we will walk through that in a picture. So let's get started. I have my Minikube up and running. So if I do Minikube status, you will see my Minikube up and running. And first thing you will need to do is get list of add-ons, as here we will need to use mini matrix server. If you don't have that enable, I have provided the command to enable that add-on. The command is here, minikube add-ons enable matrix server. Now matrix server is used to fetch the utilization of resources per pod or per node. There is a command for that. The command is kubectl top, and then you can do node, which will give you the basically CPU memory utilization of that particular node. We can see it's very idle now. And I have cloned the GitHub repository. I'm already in the horizontal pod autoscaler directory. So let's create the deployment first. Then we will create service. So let's first say if deployment is created. and my deployment is created. It's in ready status. It has deployed the pod, but it's not ready to serve the request yet because it's doing the readiness and liveness prop check. If I do get pod, I will see one pod in running state. It's basically going through the health check. And now let's create the service. And let's see the service is created properly. So service is created. We are using node port to expose the application to outside the world. Now I will run for this commands, which is already available in README, to get the application URL. And you can see application URL is a Minikube IP along with the port bound to port 80 of the service. And if I try to open this in the browser, we will be able to access the node application. Now we are good. Let's create the autoscaler. And you can see the autoscale horizontal pod autoscaler is created. Let's see how we are doing with that. So you can see right now the HPA is created. It's referencing the deployment node version deployment. It's still trying to fetch the status of the target. You can see minimum pods is 1 as we have specified, max pod 0, replicas 0 as of now because it's still trying to get the detail of how many replicas are running, what is the CPU utilization of that, and that is happening through a metric server because metric server provides the API for horizontal pod autoscaler to fetch the resource utilization of a pod. It will take some time. If we describe this horizontal pod autoscaler, then we will see that it's trying to fetch the matrix, and it failed in one first try, but it will get it in a couple of more tries, and you can see now it got it. The CPU utilization as of now is 6%, and we can do that using the top command as well. So we can do a top pod, and we will need name of the pod. So let me first get name of the pod, and we can do the command, and you can see the CPU utilization is to 3M, which is 6% in the case of the resource limit that we have provided. So it's very idle. Now let me split the terminal into two, and I will run the command to increase some traffic. So the command which we are running is this. I'm just running a bash while loop to do a call request on the URL, and let me watch the horizontal pod autoscaler. And as soon as we hit the request, you will see that the bus it increases the CPU utilization and number of replicas, current replicas will increase over the period of time. So you can see the while loop is doing its job. Let me actually create one more session to do the same thing so that we can increase the traffic quickly. And you can see now we have two threads running, making concurrent request to the pod, to the particular deployment on the service. And in couple of seconds we will see that the horizontal pod autoscaler is trying to scale the services by to little bit more. And you can see the CPU utilization now is 108%, which is obviously the average of more than average of 50% that we have provided. So now it will try to increase the replicas from 1 to 3 in this case because it's more than 50%. So, and if we add more traffic, it will try to scale it more. Now let's say if we kill the heavy traffic, then it will recognize that CPU is now being idle, CPU usage is now being idle, and soon it will start decreasing the number of replicas from 3 to 2 and to 1. and it uses the grace cycle grace period that we have configured in the readiness probe, which is 30 seconds in our case. So that's how horizontal pod autoscaler can help you to autoscale your application according to the traffic, according to the CPU usage, which makes it very easy, for your application to to manage heavy traffic. And one of the best use case for this is Pokemon Go application. Please do read the blog about the Pokemon Go application experience with Kubernetes on GCP. So with that, we are almost done with the demo. Thank you for watching the video. If you guys have any question, feel free to add your question in the comment. Uh, and if you like my videos, if you learned something new, please give me thumbs up and subscribe to my channel. Thank you for watching. Bye bye.